What did you say?
Hello, how are you today? No, I'm not eating a Butterfinger during class. It's not been that kind of a day. It's been awesome. I don't know. I'm eating one of those spinner things. I'm really close. This girl, really? This girl in 6th period gives me hers during class, so I have to like sit there and spin it when I talk to her and stuff. No, she just lets me hold hers during class. It's Brandy.
I want it. What period is it?
6th period. You can't have it. No, it's fine. I cannot believe the way my YouTube video is declining now. Good grief. Somebody please help me with these bell ringers. Sadly, 1st, 3rd period, whoever they are, those last people in here, we only got through like 3 examples today. It was slow. I'm hoping we can speed it up a bit. Please help.
For number 1, I got J equals 30.
Can you help me get there?
I first subtracted 4.30 from 6.78 and got 2.45 J minus 5.2 equals 2.7.
Yes, ma'am.
Can we have William Browner to check out, please?
Yes, ma'am.
Okay.
It's like I was psychic. I knew he was going to leave, therefore I started recording. Oh, okay. He was what?
2.15.
Okay, now what?
And then I added 5.2 and got 2.45 J equals 7.35. And then I divided by 2.45 and got J.
Oh, sorry.
It's you now. How did you not know? Now what? I want to. Are you cold?
Nope.
You're hot?
Yep.
Okay. I made it weird. Okay, somebody with a calculator. Lord Jesus, help us now. Hannah, you're having to do it all today. Surely someone else can press the buttons on the calculator.
Sorry.
2? Wasn't it 15.14? We probably better be specific. What's the other one?
15.
So now what? Okay. So glad you know math today. Don't talk anymore. Or at least not through the bell ringers. I would love to hear from somebody in that bag group on how to do the second one.
Oh, I got it.
Awesome. What's the answer? Great. Give me some math to show.
So each number, so that's 3.
What's mean? What word did you say? How do you do that? Ma'am, go ahead and start telling me.
Add all of them together and then divide it.
My bad, I'm
And you got? And which is? Okay, but hey, he said that, and that looks good. Nice. Right?
Yeah.
Now what?
And the median.
What's the median?
Middle. So you put them in least greatest.
Thankfully, they already are. I guess that's what you're related to.
And you do something.
But what do you do when there are 4 numbers? Which one's the middle?
Add 2 together and then divide it by 2. That's not.
But we got 9 both times, so it's not 9?
It's 0.
Oh. I was glad to have any help from anybody, especially when somebody told me the mean was the lowest number. Do you really want to point this out today? Do you really want to point this out? I don't think you do. Jalen didn't say anything. Jalea helped me get to the mean, and then after that, yes, we all took over because it was lasting way too long. I will. Stupid people getting stupider, I'm telling you. Okay. What did I say that kid in second period said? That's mean. I realize that's mean. Stop being stupid and I'll stop saying mean things.
Stupid's not a nice word.
I didn't say it was a nice word. In no way did I defend my statement. I acknowledge it as unkind. I'm working on that. However, thankfully, my IQ level has not dropped, although if it is who you hang out with that determines that, it is not looking good at the moment. Somebody help me get out of this mess that I've gotten myself into. No, I'm staring at the learning target because there's words I need to actually say about that and get off my little jokes for the day. I can graph quadratic functions using different forms of quadratic equations. We're going to talk about standard form, intercept form, and vertex form. Someone help me. What is standard form?
The long one.
I need somebody to plug in here. What is standard form? Ma'am, shout it out for me. Please help me.
I thought it was A something.
I thought it was S.
A Y. I mean B Y.
Okay, minus C.
Yeah, that's what I said.
Minus. Plus. I don't know.
Yeah, AX
Plus B.
plus B1.
I think it's
BY? No.
X. I just said
That's I said that.
This was for what?
Nice.
I said why?
So that's not right, guys.
Linear equation.
I think it's
Are we doing linear equations today?
Not that.
You wrote that.
Not on my handout, I sure didn't.
AX plus
AX.
plus C.
I put in the plus C. That was me. I did that. This is why I'm talking about, people. This is why I'm frustrated. Yeah, I already made fun of poor geometry with their area formula woes. I'm mad at you for not knowing that because, my goodness, we've been factoring and talking about, well, if A is 1, you do normal factoring. If A is bigger than 1, you use the ninja star. Since before spring break. So probably, if we really think about it, we've been doing that since the end of February. It is now the end of April. For 2 months we've been staring at this. And we didn't know that was standard form. Lord bless us. Okay. We're going to let that go there. So what have we been doing lately? What were you doing yesterday? Yes, we're still on quadratics. Be specific. What were you doing with quadratics? You were finding their zeros or finding their roots by, what were you doing yesterday? Factoring. So we've been finding their zeros or roots by factoring, and we've also been finding their graphs. Tell me stuff about the graph of a quadratic function. It's shaped like a bowl. What is it actually called? A parabola, and there are things we're going to look for with our parabola. What things do we need to know in order to graph? It would help if we knew the zeros or the roots. It would help if we knew the vertex. It would help if we knew the axis of symmetry. And it wouldn't hurt if we knew, there's one more. Wouldn't hurt if we knew that y-intercept. Sure wouldn't. Okay, so you've been not using your brain. Not that you don't have one, you do have one. But you've been asking Desmos or a graphing calculator to graph the function for you. Today we're going to talk about how to do it from the equation without using anything but your brain. How we can go from here to a graph, and that be it. So let's start with example 1. What is A, what is B, and what is C? I have two different answers. Is A x squared or is A 1? A is 1. What is B? -2. And what is C? -3. Okay, so first of all, we need to be able to identify A, B, and C. I honestly wouldn't write it from here on out if you know how to find it. Okay, the first thing we normally talk about with a parabola, and here I will show you with my face. We need to know if it opens up or down. How do you determine that? Like this one opens which way and why?
By C.
How do you know? You've seen equations like this. Like, how do you know which way it opens? Ma'am. It does, but why? It opens up, I'll give you that, but why does it open up? Because the A is positive. All the ones we were doing with another way to factoring had positive A's. So they were all opening up. If A is bigger than 0, it opens up. Okay, so let's go ahead and look at example 2. How will example 2 open? Down. What is A? Negative 1. So we know since it's a negative, it ends up opening down. So we're going to have a sad face. Okay, so life's looking pretty good. We know if it opens up or down. Sure would be nice to find that axis of symmetry. There is actually a formula, and if you know it, you can instantly find that axis of symmetry. Your axis of symmetry formula is negative b over 2a. So what is my axis of symmetry for this example then?
It's negative 0.3. What? No?
I thought negative b would be negative negative 2, so it ends up being positive 2 in the numerator. In the denominator, it's 2 times a, so 2 times 1, which is just 2. I thought 2 over 2 reduced to 1.
Oh shoot, I have that one.
So my axis of symmetry is at 1. Well, you got another shot because we're doing two things at once. Can you find the axis of symmetry for our second example?
Negative 2.
Everyone else get negative 2? But I didn't. Negative b would be negative 4 over 2 times a. A is negative 1. I ended up getting positive 2. Negative 4 over negative 2 is positive 2.
Shoot. I can't get this right at all.
It's a negative b, that's the problem.
No. It was actually the negative 1.
Hmm.
I thought it was positive.
Okay, so we have that axis of symmetry. There is a point on the parabola that touches the axis of symmetry. What point is that? Yeah, the vertex touches the axis of symmetry. So the vertex and the axis of symmetry, they go hand in hand. We know the x-coordinate of our vertex if we know our axis of symmetry. So we already know our vertex is at 1 something or other. We've got to figure out that y value. Just like on this one, we already know our vertex is at 2 something or other. We've just got to figure out that y value. How do we, given an x value, determine a y value? Sadly, you leave me in like over a month. You know how to do this. I'm given an x.
Oh,
How do I solve?
It's -3. It's C. C is the y value, isn't it? You saying it? What? Never mind.
If I'm told x is 1 and I need to know y, aren't I supposed to go to my equation and everywhere I see an x put a 1? So 1 squared minus 2 times 1 minus 3. So you end up getting what number? What is the number for y? Lord. Say it again. -4. Because 1 minus 2 is -1. -1 minus 3 is -4. So it's 1, -4 is my vertex. So I'll put a point at 1, -1, -2, -3, -4. If I go do the same thing on my other example, because I like to work on 2 things out at once today, everywhere I see an x, I'm going to put in a 2. How did you get 9?
I got 1.
I have -4 plus 8 minus 3. So it ends up being -7 plus 8. You should just get 1. 8 minus 7 is 1.
3 equals 5. -8 plus 5 equals 1.
That's 1. Did you do the negative sign on the outside? Probably not. You did +4 instead of -4.
Yeah, I did positive.
You did +4 and -4. But notice our formula, it went up here, it didn't say -x squared. It didn't say that. It said negative on the outside, plugging your number squared. So I did negative on the outside, plugged in my number squared. Okay, so my vertex is at 2, 1. So far I've got my axis of symmetry, I've got my vertex. What else could I find? What else do I need to know? I need to know the roots, and we'll do that on one. Example 2 does not look like fun. We get confused when we have to factor and there's a negative out front. But we can find the roots on number 1. What are the roots on example 1? I need 2 things that multiply to -3 and add to -2. -3 and 1, right? You said it was -3 and 1. It ends up being the opposite sign on the graph. It's what we were talking about yesterday, how we did the x minus r1, x minus r2. It ends up being the opposite side. So our roots are going to be at actually +3 and -1. So 1, 2, 3, and -1. But finding the roots can sometimes be a challenge, like on example 2 where it's hard to factor, or if you tried like any number after 9 on your another way to factor it, got harder and harder factoring. Sometimes it's a little ridiculous. Sometimes you don't want to find the roots. It takes too long. What else could we find? We found the axis of symmetry. We found the vertex. We found the roots. We could find the y-intercept. So let's see if we can't find that y-intercept. How do you find a y-intercept? How do you find a y-intercept? And y equals mx plus b, you know it was the b. Yeah, I'll give you that. How do you find the y-intercept? This is not y equals mx plus b. What is a y-intercept? Okay, so it crosses the y-axis. So is this a y-intercept? This point right here? Is it realistic for our graph? Okay, so, but it could be this one. What's the coordinates for this point? Okay, what's the coordinates for this point? What's the coordinates for this point? What number do you keep repeating for that x value?
0.
So a y-intercept happens when x is 0. So what should you do in that equation then?
Y equals 0. Wait, nope, I'm done.
What should I do in that equation then? Everywhere you see an x, put a 0. So 0 squared minus 2 times 0 minus 3. Should I have actually bothered to write that down? Should I have actually bothered to write that down? No.
It's just negative.
It ends up being just negative 3 because looking at my equation, that guy has an x, he goes away. That guy has an x, he goes away. It's going to be negative 3. I know my intercept is out negative 1, negative 2, negative 3. Okay, where is my y-intercept on our second example?
Negative 3.
Okay, tell me something that is really cool about parabolas. What makes them special? There's another term we haven't used that could possibly be useful now. Let me tell you what I'm thinking. I see this point here, and I think I can add another point to my graph because of that one. Because there's something special about parabolas. It starts with an S. They're symmetric. Parabolas are symmetric. So if there's a point 1 to the left of the axis of symmetry, there's going to be 1 to the right. This one was 2 to the left, so this one's 2 to the right. This happens on purpose. Yay, parabolas for being symmetric. So looking down here, I can add a point down here as well. This one was 2 to the left, so this would be 2 to the right. And we've not even found the zeros, but we already have 3 points on that graph. We can make a pretty decent graph now. We've gone a little overboard on example 1. And just when you thought your brain was about to explode, because my gosh, you didn't realize how many things you really did deep down know about parabolas, I would tell you that if the A is a positive or a negative 1, so like a normal factoring 1, if you're still stuck on this factoring thing, a normal factoring 1, if you just know the vertex, you can figure out the rest of the graph from just the vertex. Because quadratics are x squared. So those perfect squares suddenly come in handy. It ends up being, what's 1 squared? 1. Over 1 up 1. 2 squared? Over 2. 1, 2 up 1, 2, 3, 4. What's 3 squared? Over 3. 1, 2, 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 1 up 1. Over 2 up 4. It works on both sides because it's symmetric. 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It also works on both sides because 3 squared is 9 and negative 3 squared is 9. And if I had room, I could go over 4 up 16, over 5 up 25. Those perfect squares will always work if the A is 1 or negative 1. If the A is a fraction, we discussed fractions make me fat, so that normal counting method is not going to work. It's not going to be your normal looking parabola. And if it's a whole number in front that makes me skinny, it's not going to work then either. You're going to have to work a little harder at it. Okay, if you would like to connect your dots at this time, that would be fine. She's got a concert? Earth Alive? And again, it still happens on this bottom one. It's over 1, down 1. Over 2, down 1, 2, 3, 4. Oh, look, we already had a point there. Over 2, down 1, 2, 3, 4. Already had a point there. And I can't, there's not enough room to go over 3, down 9 on this one. So graphing a parabola, it's as easy as graphing a line. Not a little easier because it's symmetric. Is there anyone like just intently lost at this point? Okay, well, oh, y'all are so smart. I love you so much sometimes. I'm not going to do that to you, though. What we'll do is we'll stop here, and I'm going to give you 4 for you to do. God bless you on your own paper. Can you believe it? Hadn't made you work on your own paper in forever. I'm going to give you some to do on your own paper, and what's really annoying is I'm going to pick ones from the packet you just turned in. So ones you've seen already. Let's see them again. This time actually graph them on our own without using Desmos. You need to do y equals x squared minus 6x minus 7. You need to do y equals x squared minus 9x plus 20. There's potential. Some of these are not going to be easy graphs. I'm just picking random ones that you've seen before. I'm sorry. I love you. And the third one, let's do y equals negative x squared plus 3x minus 2. Let's make sure we're on the same page. Zach needs to graph these using his own knowledge, meaning he's found that axis of symmetry. Maybe he found those roots. It's okay if he didn't. I understand if maybe he found the vertex and the intercepts, and then he had like 4 or 5 points, so he was good to go. You want to have at least 4 points, a minimum I'm going to ask on each graph. And Lord knows I'd love to see where Zach came up with these things. If he says the axis of symmetry is at 3, I would love to see where he did negative b over 2a and actually for real found it was at 3. Not Desmos told him. If I don't see Zach's work, then how do I know Zach did it and not Desmos? Although if you really ask Desmos, it could still do this for you too. Sad day.